Welcome everyone that's joined us for the webinar. In this webinar, we'll introduce the Stope Optimizer, which is new to Sepik, a 2019 software release. Well, firstly, before I continue, let me give a brief introduction of myself. My name is Linda Bateman. I've been with Dassault System here in Perth, Western Australia, since May of this year. I've got over 20 years experience in the mining industry as a geologist and most recently involved with project evaluation, project optimization studies. So before we get into looking at the Stope Optimizer, I'd like to present this question. As an industry, where are we on this pyramid in terms of stability, excellence, and agility? Where would you put your company, project, or even yourself on that triangle? When we're talking about a project, how do we qualify or quantify the value of our project if the landscape changes? Does our project have operational stability? How sensitive is the project to change, whether it's economic drivers or by other factors or unplanned events during the life of the project? How agile are we to that change? We often work to a plan A. What if we need a plan B or plan C? And is in fact plan A the right plan or the optimum plan? What defines optimum for your project? That could be factors in challenging ground condition or recovery or dilution factors, or even depending on where your mine is, other social or economic considerations. Most of us have been involved with a project where project conditions have changed or are well down the path of a project evaluation when new or unplanned factors come from left field. The work and critically the time it takes can be significant to reevaluate or start again on a project. This is where the Stope Optimizer can help. The Stope Optimizer, as I said, is new to Sepik 219 and provides the mine planner the ability to automate the stope design process for strategic planning, analyse and determine the optimal stope shapes through the ability to rapidly generate and review results based on a variety of economic parameters and practical mining constraints. It allows rapid evaluation of numerous scenarios to develop, a plan A, B, C, and so on towards defining or finding the optimum plan. Let's have a look at the agenda for today. So we'll begin with looking just an overview of the Stope Optimizer. What is it? We'll look at the fundamentals to get going with the Stope Optimizer in Sepik 219. We'll look at other functions available to you in the Stope Optimizer that really will let you find or discover optimum project value. We'll jump to Sepik and have a look at what the optimizer looks like in Sepik. We'll come back to the presentation and have a look at the benefits of, why would you use it? Why would you want to have it in your suite of underground tools? And we'll finish off with questions. As mentioned, please type in questions as we go. We'll compile them and save them to the end of the presentation just to use our time more efficiently. So let's have a look at the overview. In open pit operations, optimization studies that maximize value and reduce risk of an ore body have been around for many, many years. Inputs include grade and financial models, mining practicalities governed by equipment constraints and ground conditions to generate pit shells that represent project value. The Stope Optimizer is the underground analogue to that. So let's look at some of the new functionality in a little bit more detail. I've just dot pointed some of the key features of the Stope Optimizer on this slide. So the optimizer really allows us to generate optimum stope shapes for a range of underground mining methods, provides stope shapes that maximizes recoverable resource above a cutoff, a nominated cutoff grade or value. Value might be net smelter return as an example. The value can also be a calculated attribute in your block model. The optimizer also produces stope inventories to assist with ore supply. Again, the inventory, how many stopes are produced, is really dictated by the scale and size of your project. The optimizer allows for practical mining parameters such as minimum and maximum mining widths, anticipated wall dilution. That can be on both sides of the stope. You can flex both. Minimum and maximum wall angles, and many other factors. The key point here is really you can modify the Stope Optimizer and adjust the inputs to suit your project drivers. So let's have a look at the workflow fundamentals now. So looking at this particular slide, it's really describing the workflow of the optimizer from left to right. What are the key inputs? And we'll look at just the minimum requirements needed to generate stope shells. And really, the minimum requirements is a block model with an optimization variable and also a density variable, typically dry bulk density. The only other input we need is to define the Stope framework itself. The Stope framework consists of the spatial extent. In other words, the box that the optimizer is going to work in. That can be the full block model extent or a sub area of that block model. The plane orientation of the stope that typically sits in the plane of the ore body. The section and level spacing. For stope controls, the minimum we need is global dip and strike. We need the minimum and maximum stope widths and the stope wall orientation and pillar width controls. Full stope shapes, that is defined by the section and level spacing, and that's the maximum size of the stope itself. Stope controls we'll look at in a little more detail in a tick. That allows us to create more realistic mineable shapes. The optimization controls is really the optimization variable. So that can be the value or a grade, as I mentioned earlier. The optimization cutoff, that defines the ore waste boundary for the Stope Optimizer. The output is, of course, the stope shells themselves and a summary report including tonnes and grade for each stope. Okay, a picture is worth 1,000 words, so let's see what the Stope framework setup looks like in 3D space. So a bit of context, we're looking at a north-south striking tabular ore body that's dipping at about 80 degrees to the west. So this particular mine grid, Y is north, Z is elevation or RL, and X is the easting. So the model space is defined as the blue. So that's the box that the optimizer is going to work in. The section plane, in this case it's a YZ plane. The section plane, whether it's vertical, horizontal or rotated, is dictated by the ore body orientation. For this example, it's pretty much a north-south striking ore body, so the plane orientation is also north-south vertical plane. We also need to define the section spacing, and this represents the strike extent of the stope, and also define the level spacing, and this represents the height of the stope. The model that we're looking at here, they are 20 metre by 20 metre panels, and that represents the maximum size or the full stope shape. Okay, so let's look at the other functions that are available to you in the Stope Optimizer that let you define or find the optimum project value. So I'll just recap the bare bones that really let you get started with the Stope Optimizer, just as a snapshot. And let's look at the functions that really let you have more control towards generating more realistic mineable stope shapes. You can see there's a lot packed into the optional stope controls. On the optimization controls, there's also the option of defining a head grade within a cutoff boundary, and also for the output, we can also ask the optimizer to output validation files and a more detailed report. The validation files really allow you to identify areas where a stope shape wasn't generated and let you use the verification files as a tool towards understanding why stope shapes weren't generated. The Stope, just looping back to the Stope controls, we'll look at some of these when we go and visit the Stope Optimizer in Sepik. But just a snapshot view of what the tools will allow you to do. In essence, as I've mentioned, it's going to allow you to create more realistic mineable shapes that meet your specific project needs. It will let you maximize recovered metal or maximize value. From a safety and environmental cadence, it lets you identify minimum distances from existing infrastructure to flag and avoid areas of where there's might be poor ground conditions. And really, the Stope Optimizer will let you evaluate multiple scenarios by storing project files and let you uncover or discover your plan A. The optional stope controls really give you the flexibility to handle very complex through to simple optimizing scenarios. Let's have a look at what the optimizer looks like in Sepik 2019. I'm just going to jump out of the presentation and we'll go to Sepik. I've got Sepik running in the background. It's just displaying the block model of that stope shape we were looking at earlier in the presentation. The model is coloured by gold grade, just to quickly have a look at the legend. So this could be any element. In this case, it is gold. We're looking at one particular lode in this deposit. We're not looking at the whole project area for the demonstration today. So this is what the Stope Optimizer is going to be using to generate stope shapes. I'll just close the block model. We don't need to have that open while we look at the Stope Optimizer. So let's go and have and see where it lives in Sepik. So it lives under our design menu, along with the other underground tools, which is a sensible place to put it. So when we open the Stope Shape Optimization tool, you can see it's just a series of tabbed forms, and we'll work through and have a look at each of the forms and what's available. Just to save some time, we can use a project file. I've already set up some examples like any good cooking show, and so I'll just load one of my project files so we can see what that looks like. So, of course, part of the input is telling the optimizer the block model you're going to use for the optimization run. Any output files. In this case, I'm just doing the mandatory files. I'm not worrying about specifying any verification files. And I'm also just reporting the optimization value and density. There is, if you have more elements to report, you can, of course, define those here as well, silver, copper, and so on. The Stope Framework, again, it's just defining the box that the optimizer is working in. That can be parallel to your axes, or it can be rotated in 3D space. Again, this is dictated by the strike and dip of your ore body relative to your block model coordinates. Here's where we define the section and level intervals. In this case, they will be 20 by 20 metre panels, and that will be the maximum size of the stope that will be generated. Slice definition lets us put in the global strike and dip angle conventions. If you can, of course, use a surface that defines the general trend or strike and dip of the ore body, or you can have attributes in your block model. If your surface wireframe or block model values don't extend for the full area of your ore body, the optimizer will use your default. So you should always get a stope shape generated. We can, of course, define the stope geometry. So this will really be dictated by your mining constraints in your particular project. It's, as a good rule of thumb, it's good to start with fairly broad inputs, as I've done here. This will let you generate the maximum number of stopes for your project area. And then as you start constraining or applying more meaningful constraints or realistic constraints to your stope shapes, you'll start reducing the number of stopes that you generate. We can, of course, add dilution factors. I'm not going to, for this particular run, minimum and maximum widths, as I mentioned earlier. There's also the option to define subshapes. That's quite useful. If you're not dealing, it'd be nice to think that for my ore body, I could fit perfect 20 by 20 metre shapes over the top of my ore body and capture everything. Of course, we know that's not realistic in the real world. So you can define subshapes to allow smaller stope sizes to be generated, where perhaps the ore body pinches out a long strike, or it's just purely just from the shape of the ore body if it has a plunge component to it. We can also specify development profiles if we need to, and as I mentioned earlier, we can define smoothing or post-processing options to allow more meaningful stope shapes. So imagine having your stopes, adjacent stope shapes. We want them to be smooth because in a practical mining sense, we don't want those geometries to be wildly different. We can also do constraints to structures. That can be a geological constraint. For example, we can also define a surface structure. An example might be if you've got poor hanging wall conditions. So if it's when a stope is mined, you're going to get dilution from the hanging wall. You can, of course, factor that when you're defining your stope shapes. But to start with, we're just going to look at the base case scenario. We can also define our optimization cutoff. Again, that can be a grade or a value or a calculated value. Simply define, in this case, we're using a grade as our optimization field, and I need to tell the optimizer, supply the density attribute. And of course nominating a cutoff value as well. As I mentioned, we can define a head grade. If we do define a head grade, we must define a cutoff. So the head grade, the boundary, if you like, the cutoff defines the domain or the boundary, and the head grade works within that domain that the cutoff value defines. And of course, we have our optimization or evaluation methodologies as well. So let's see what let's see what happens. So let's run this. And this will only take a few seconds because it's a fairly reasonably small data set. So we'll just go and have a look at the output, and it's in this particular folder. So there's my project file. The output is, it's a new file format, it's an SDM file format, um, and we'll see what that looks like. So we can see for this load the individual stope shapes that have been generated. They're the 20 by 20 meter full shapes. If we just query a couple of the stopes, we can see, I'll just close some of these so we can highlight and see that a little better. So we can see that each of the stope shapes have the attributes stored in them in the wireframe. So we have the object number, the stope shape name, the volume, the density, grade, and tons as well. So everything that the Stope Shape Optimizer generates are stored as attributes in the wireframe itself. So I've run several scenarios and flexed some of the inputs to the optimizer, and I've just stored them as separate project files and separate folders. Let's look at another example before we leave the optimizer. Excuse me. In this particular example, just to set some context, I've got my the ore zone, and I also have some nominal structure. This could be a fault or bad ground, or just a no-go zone that I don't want a stope shape to be generated in that area, just to provide some context. So let's have a look at the project file that I've set up for that, just as an example. So most of the inputs are the same. For the stope geometry, I've used that shape and flagged in the block model some constraints. And I've said, look, when I run the optimizer, I only want to contain material of a particular value. And I've said there must be at least 90% of that material in order for a stope shape to be generated, and to exclude any material that doesn't have that particular code value. So if we go and have a look at the shape that's been generated, we can see here, and if I just drag and drop the structure the structure back in again, just so we can see what that looks like, and we can see that the optimizer has run. I've just done full shapes. If I'd allowed subshapes, I would certainly generate additional stopes closer to that no-go zone, but I elected not to in this case. So that's just showing some of the examples of how to vary some of the inputs into the optimizer. So we'll leave Sepik now, and we'll just head back to the to our presentation. So moving on from the demonstration, let's look at why you would want to use the Stope Optimizer as part of your to evaluate your project. So the first thing that I can think of, the project optimizer lets you evaluate multiple scenarios. You can save these into project files. So you can store, the scenarios, plan A, plan B, and so on. Just the time efficiencies of generating stope shapes. The manual process of generating hundreds of stope shapes, you may get part way through doing design, some unplanned event may happen, back to square one. So just having the ability to just supply input and have those inputs for design, cost, and other factors, to have an optimizer generate those stope shells for you just saves a huge amount of time. The Stope Optimizer generates stope inventories that may contain, as I've mentioned, hundreds of stope shapes. These will assist you with evaluating ore availability or ore balances of your project. The optimizer allows you to generate practical mineable shapes as a start point for the design phase of your project. Part of that is also governance and compliance, transparency of your data, the inputs and results in terms of the factors that we used to generate the stope shapes is an invaluable tool for any mine planner. So that really brings us to the end of the presentation. And now we'll pause and have a look for questions that you've submitted. I've got a couple of questions just to feed back to you. Some people have asked what type of block models can we use with the Stope Optimizer. We can of course use a Sepik block model and also Vulkan and Bateman block models can be used in Sepik and used with the Stope Optimizer. Another question is, how long does the Stope Optimizer take to generate stopes? Of course, today, we're using canned data just to save time and manage time limitations. Again, that's driven by just the size of your particular model that you're working on. If you have to divide your project area up into subdomains, of course, stope geometries that might suit one particular part of your ore body may not be practical in other areas of the ore body. So just the time that you might need to just subdivide your project area is a factor. Some of the real data sets that I've been using with the Stope Optimizer, it can be anything from 15 minutes up to 40, 45 minutes. The things that can impact the speed of the optimizer, things like the rotation. So if your Stope framework is rotated in 3D space compared to your mine grid axes, of course that will take the optimizer longer to optimize and generate stope shapes. What we can do, we do have 3 sessions. We can perhaps compile some questions from all the sessions and share that with all the attendees. I'll, pardon me, hand back to Juliana and just thank everyone for joining us today and participating in today's webinar.